Program 1.7.1. I wanted to show you this thing. This we're still in early career mode, of course, but I made this craft, and there's no reason to make you to have you watch me make it. It took a lot of time. Anyway, this is early career, and we now have our very first breaking ground hinges. Let me show you these hinges. First, this is the one on top. Excuse me. This is the one on top. And what you have is these target angles that go like this. Okay, and then I have a hinge down here. And it also has a target angle. Alright, now the hinges have a sense of timing or a traverse rate. They also want to know whether they're motorized or standing there loose. I've got it on maximum motor size and maximum output. That burns the most electricity, but it also has the most strength and resistance. Now these do have a tension in them, and sometimes it's more than the motor. But you notice this has a traverse rate. I'm going to go ahead and put that there like that. It's 90, and then our traverse rate on this hinge is 122. So I need this hinge to move just a little faster than that, and that's the only settings I've done. We do have hinge controllers or controllable hinges or something. I saw it on the interview, or the preview, and then I saw some DLC updates, and I noticed that we have some kind of controller mechanism. The only controller I've used was custom one, and I just have all the hinges going when I push button number 1. Now, controllers down here, there's nothing below them, so that's probably either in the future or it's a whole different hinge altogether with some kind of controller control. But this works for now. And I had to set the rate here because what happened is my wingtip hit the ground, and that before it went into action, and it may or may not get stuck. Both of the hinges are set up the same, they're just at different levels. I guess I could put this on a hinge and flip it around and tuck it underneath, or I could probably fold it over at an angle and set one of these up to fold under and the other one to pretty much stay where it's at. Maybe even lean a little more. Let me show you how these work real quick. How you set them up, because they have a range. You can see this one goes from there to there. Okay, and then this hinge here has a range too. And let's look, see. Of course, the other hinge is working at the same time as this one. So actually it's working faster. So I should speed this hinge up to even maybe, let's go as fast as we can on 180. Anyway, let me show you this, because maybe I want to go a little closer. So I pull this like this, take that off, and that allows me to move this a little closer. So just put it right where you want it. Okay, and then you look at the number, it says 19, and then you set this on 19. Now you'll have a range from there to there. And that's just the one hinge arm. And the other hinge arms at a very high speed. Did you see us speed it up? It's going to flip it up. So let's save that. And we just made an adjustment. We just tightened it up a little. We should probably take this hinge arm too. And okay, that looks pretty good. So then what we do is we move this until that angle limit disappears. And you saw it just give me one click. That's good. So, but we're just looking at one hinge now, but let's see the range. It looks like the way I had it set up before, that it would, if something went wrong, it would never cross over onto itself or crash into itself. So I had a different idea going there. Here I wanted to show you how to kind of set the angles and what the hinge contraption looked like and how I used the custom action groups to control it. So, and we don't have controllers yet. Now these wings kind of, let's just go ahead and go out there. These wings flap like birds, and they're not solid. They have tension on them, probably motors that have a certain amount of slip and resistance and maximum rates. So anyway, when you have hinges, you need electricity. So there's my battery. I'm going to show you the fold out. Yeah, I noticed you have to watch real close, but that did close quicker. Now, it sucks batteries. Look. See, I'm already below 200. That was already 50 units of electricity just to do that. But never fear, because our jet engines produce electricity. Some engines only produce electricity at full throttle. Some engines produce electricity at any throttle. Maybe even idle. Don't hold me to that. Let me put it on chase. Oh, look. I've gotten so busy, I've neglected my #1 priority, and that's my unfolding of the wings. Is it too late? I'm almost to the end of the runway. Does anyone know the answer to that? Do you? Alright, hopefully that was with some spectacular movie effect flair. So if you noticed, I climb, I lose speed, and that's at a sharp climb rate above 10. I'm losing speed, but if you put it back down, like let's say a nice little comfortable 5. See if we can hold it at 5. Yep, I'm holding it at 5 and above. And it was going up in speed. That's what I was watching. Now, what I'm going to do is straighten this craft out. I'm going to put it up on 0. It's going to fall back below 0 and put itself on -5. Now, look, no hands. Now here's the thing, if we don't hit the water first. See me sitting back in my chair? And the reason is because I know as we go down and increase in speed, the vertical speed is going to slowly rise back to 0. If you have your, what we call your airplane not dialed in, it's going to do this thing that goes up and down, up and down, up and down. And this is a trade-off of speed and altitude, and then it keeps trading back and forth. And look, lo and behold, we are at 0. Let's go into the pilot's cockpit and look at his vertical speed control. It's a little more precise. Alright, we've just surpassed exact zero, precise zero. We'll probably see our altitude here holding or rising slowly, and that's a good thing. And I have not touched the controls. The only thing I've touched is mouse and a keyboard and views, and no controls. This airplane has been flying itself since I put it back on zero. Now look, the wings are pretty solid, and looks like our maximum cruising speed is going to be 125 at level flight. Now we have a thing called a stall speed. I'm going to call that 50 meters per second. That's when you have no choice but to point your nose straight towards the ground until you get up to probably 75. So we have a little comfort zone between 50 and 75. I don't take off until I hit 75, and I don't land above 75. I want to land right on 75, maybe 4. 74 is better than 76. But 50, I die. And I know that. So, anyway, if you can see here, I have left room to remove this engine and put 2 on this in this spot. Or you can leave this engine on and put 2 at this spot. But basically, you'll double this. You double that, you're going to be running about 240. Okay, you run 3, you're going to be running 240 plus 120, 360. So 3 engines is 360. Now, I don't know what to call this because of the flappy wing thing. So let's turn. I want to show you the wings flap a little bit. So I turn, I pull back on the stick. You can see me losing altitude. So rather than hit the water, I come back, and now I'm going to execute turn and no drop in vertical speed just by running my circle across that center thing. Now that's, did I just run over 270? Yes, I did. So I almost can see Kerbal Space at right about that mark. Alright, so now I let go of the craft, and I notice if I don't go down below 5, and unfortunately I'm pretty close to the water, but I could just sit here as a pilot and do nothing. Alright, so that was a turn, and what we did is we lost speed and we lost altitude to execute both. And then we also, by doing that corrective turn, I lost a lot of speed. If I would have just done the lose altitude turn, I probably could have done it without losing speed, or I could have done the don't lose altitude turn like you saw me go into the correction at the major cost of speed. So it's always speed for altitude. The wings help us navigate through it, but they really... Wings are little more than a surfboard under a surfer's feet. Okay? There's only so much it can do, and it still needs the wave. Without the surfboard, the surfer can't surf at all. So it's kind of strange. Like the mighty forces, the ocean and the waves and the pressure and the tidal force, and then it comes down next to the surfer's strength and his skill level and what he has taught himself. So, and then what's left? A plank of wood with a fin on it. Well, I mean, I know they make them out of fiberglass. They used to make them when I was a kid, like 10 foot long. You could actually walk out on the front of them because the board was so heavy. It was the board that was surfing, and the surfer was just a rider. Now they're these little fiberglass things. They're slippery, and the surfers definitely, it's more than the board, for sure. Anyway, it's all short-lived. It all ends too quick. And surfing's kind of silly if you think about it. You could drown. The water's dropping out from under you. You're bashing into rocks below. It's definitely, you have to be a fool like a pilot, I guess. Anyway, lowering the landing gear and backing the speed off. Oops, I hit the button. Wow, look, it still flies. But before I crash, let me correct. Is it too late? Wow, we pushed the button and it didn't lose that much. What it did is it kind of acted as an altitude. It diminished my altitude quickly, and then when I came out, I'm almost near my death stall speed, 50. See, 50 I die, and I never went above it to 51. Oh, okay. That was a really hard Mayday emergency landing, shutting down the folding the wings and pressing the brake, and not too hard, just little pumps. We're a little bit top heavy on the right to left when we're folded. But anyway, thank you for viewing my folded wing video, and let me just go ahead and unfold them one more time while you're watching. Anyway, thanks for coming, thanks for watching.